couple things that, just to reiterate, maybe you heard these in class, is you only work on one side or the other. So you have to determine which is the more complicated side, which kind of goes against your intuition, your math intuition, like that, but you actually work on whatever is the more complicated side. So the left side to me is slightly more complicated than the right. You could maybe make an argument either way here, but let's just work on the left side. I'm going to send you by the chat here a really good trig cheat sheet. I would recommend printing this out. I'm going to draw from this a lot today. There's a lot of stuff here that you're going to want to remember in preparation for your test. When you get to college, they usually give you a cheat sheet, a one-page thing. High school, they don't really do that.
I don't know how many. There shouldn't be all the identities we're using tonight. I do have my notes on them with me right now.
Good. So we're going to use these, and the first one's the most important one. You're going to use that over and over again. Since the answer only has cosine squared in it, what we're trying to get to, we're going to want to change sine squared. So if you look at this first identity, sine squared theta, or whatever variable you have, equals 1 minus cosine squared theta.
Yeah.
So we're going to write on the left side here, cosine squared beta minus parentheses 1 minus cosine squared beta. So we're going to distribute the negative, minus 1 plus cosine squared beta, combine like terms. There's two of them, 2 cosine squared beta minus 1. We got it. So whenever you see squareds, you're probably going to use a Pythagorean identity. That's the association you want to make for this type of problem. All right, let's look at number 8.
Okay.
8. This is another strategy that you're going to use quite a bit here. The strategy is, let me snip this in, is you want to get everything in terms of sine and cosine. Okay, so that's another kind of big one you'll see over and over again.
Yeah.
So the left-hand side is the more complicated side.
Yeah, pretty obvious.
Pretty obvious. So we're going to just transition everything into sine and cosine. So tangent is sine x
over cosine,
cosine x. Okay. Sometimes things get worse before they get better here. Like on the right-hand side here, I'm sorry, the left side, it becomes sine squared x over cosine x.
Yeah.
Okay, and on the other one, it's over 1. We really want to make this a common denominator. What would the common denominator be?
We would want to multiply. We want it to be cosine x on both sides.
Yeah, so multiply these top and bottom by cosine x.
Yeah.
So you got cosine squared x plus sine squared x all over cosine x. I mentioned those identities. You're going to need them a lot, the Pythagorean ones. What does the numerator become?
The numerator becomes 1 over cosine x, which is going to end up being secant x.
Yes. Now, like one of the very first times I met you, and I don't know if you're still this way, there was like this like, you didn't want to put all the steps down. You are being 100% graded on writing every line in this.
Yes.
So you have to write everything down, even though maybe you are such a good math student, you might be like, oh, I can just see it. It's that. You got to write it down.
His name's Mr. Collins. He's very big writing every step.
Yeah. Now, for some problems, like that's probably over the top, not unnecessary, but for here, that is totally what they're emphasizing. So that's just the way it's going to be when you're doing these problems.
Yeah.
Okay, let me grab another one here for us to work on. I'm going to look at 14 next, if that's okay.
All right.
All right, so 14, my opinion is that the left side is more complicated than the right-hand side.
I would definitely agree.
Yeah. There's a lot here, like, okay, secant to the power of 6, secant to the power of 4th. You probably already see that these are the same in both. Your instructor may have put like a PowerPoint up, or in your book, it might say like one of the strategies is you just try something and hope it works out. What do you think? What would you do here? Like, what does your intuition tell you to do on this?
Yeah.
There's not a wrong here, but but just I'd like to kind of get a feel for what you might do.
I'm not sure. I might distribute the secants to both things and just see if something works out like nicer.
That will actually make it no more helpful. So generally you want to factor, like if there is kind of a
Oh, yeah,
preference,
yeah.
yeah. So you factor out secant x, tangent x, and that leaves you with secant to the 6th x minus secant to the 4x. Now, I mean, we haven't
Okay.
really made it any better, but we'll keep going here. What is common to both of these?
Secant to the 4th x.
Yes, that gives you secant squared x minus 1. Your head should say, oh, that's an identity. Let me go
It
grab them again.
is. It
What
should
is it?
be.
Which one is it?
It would be the second one. It would be secant squared is tangent squared plus 1.
But we have secant squared x minus 1. So you either have to visually say, oh, that one moves over, or you have to solve it. But this right here gets replaced with tangent squared x.
Okay.
Because that if you subtract 1 from both
Oh,
sides.
I see.
Okay. Now there's some problems. Some instructors will actually like kind of throw you off. They'll make this wrong. They'll make this +1 and make you think you can do that. Let's hope you don't have that instructor here. We're just going to bring this down here. Secant to the 4th x, secant x, tangent x. Okay, now these multiply. So that's tangent cubed x. And then secant multiplies with secant, that's secant to the 5th x.
All right.
And that is what we were looking for. Like, you always want to know your target. You know, I remember you played hockey. I don't know if you still do. You know, it's kind of
I
like
definitely still do.
you still do. So you got to like, I want to score. I'm going that direction, or you're following. Like, you need to know where you're going to kind of give you an idea if you're getting closer or not to the actual answer here.
Yes.
All right, so 16 is a good one for us to look at next.
Very cool.
All right. On the left side here, go ahead.
No, you're
Okay.
fine. We have to.
On the left side here, it's definitely more complicated. This is,
Yes.
I call this a non-obvious thing to do. And
you're gonna multiply by I know what I know what you're supposed to do. I just don't know what it's called.
It's called the conjugate.
Conjugate, yeah.
Okay. And the reason is because you want it to turn into an identity.
Exactly.
So on the bottom here, and this is another thing, like you're used to foiling, you don't always want to foil. So just, you know, like maybe you will in this problem, but it's not always like, yeah, you're going to for sure foil everything. Because the bottom goes to sine squared.
Yeah.
Okay. And we're trying to get to secant theta. So there's more to do on the top here. So let me drag this down a little bit. The top, you know, this secant is really 1 over cosine theta minus 1 plus cosine theta. Like here, I guess I'm going to tell you to foil, because like when you foil the cosine theta times 1 over cosine theta, that makes a 1. So let's just try that. You know, sometimes you guys got to try stuff. So 1 over cosine theta in the numerator minus 1 plus 1 minus cosine theta. That's the numerator. That's when you FOIL all over sine squared theta. And that's another point here. So like we worked on the numerator and the denominator in the same step. Some instructors don't want you to do that. I'm not sure what to suggest on that one, but you can think about your notes, think you know what the instructor does.
Yeah.
These cancel. Okay, so now in the numerator we have 1 over cosine theta minus cosine theta all over sine squared theta, and we're trying to get to secant theta. So we're in some ways we haven't made this any better, but you know, some ways we have. We want to make a common denominator here, so that's cosine theta. So it becomes 1 minus cosine squared theta over cosine theta all over sine squared theta. What do you see? What can we simplify here?
I'm thinking it might be the 1 minus cosine squared because my first idea is
Yeah, so that's,
Pythagorean identity
yeah, so that's sine squared theta
squared
over
over
cosine
cosine,
theta. And then we're going to multiply by the reciprocal of this.
which is, yeah.
And then we're really close here. You have to show these canceling. You have to show it's 1 over cosine theta, which is secant theta.
Mhm.
All right, so like this is a really good problem that we just did. I'm going to snip it in one more time. If you're trying to figure out what your instructor might put on the test, one of the things you can do is you actually can like swap out secant for cosecant, cosine for sine. You see how I did that here? And
Yeah.
this is how your instructor changes like the problem, but it's just like one you did. You do the exact same thing. You multiply by the conjugate. You do what the numerator, making foiling, making a common denominator. So my point is that if you're trying to figure out like what could they ask you, it would be the same question you might see in one of these problems, but they're just changing like to their cofunctions. So sine's cofunction is cosine, secant is cosecant, tangent is cotangents.
Yeah.
Okay. All right. So let's look at another problem here. Number 20. Yeah. All right. Which side do you think we should work on?
I don't know. It kind of looks like the left side looks more.
Yeah. So
has
like
more to do.
to me, fractions are more complicated than not fractions.
Yeah.
Although you could say, hey, Matthew, if I just take the reciprocal of these, it becomes this on the right. So it's kind of I mean, I don't really like this question, but the reciprocals of both of these just become that.
Yeah.
Does your instructor tend to give you kind of like, I don't want to say trick questions, but like if you see something they're very short, or is he like kind of the longer ones where you have to really work out a lot of steps?
It's definitely really long questions that take like
Yeah. Okay.
10
So
to 15 minutes to do.
Great. We're all right. Let's look at 21 here.
Oh yeah, there's a few we've done it actually in class that have tended to be really difficult. I actually haven't done 21, but it's supposed to be a good question.
Yeah, it is. It is. Because of this -1 over here. Okay, so that like all of a sudden that's like, whoa, what do I do? Well, if you didn't have this -1, what would you do?
Probably multiplied by the conjugate.
Right. So you would take cosine theta, cotangent theta, 1 minus sine theta, and you would go 1 plus sine theta, 1 plus sine theta. Okay, and then we'll just leave this -1 here for the moment. So the bottom becomes 1 minus sine squared theta, which becomes which identity?
It would be cosine squared.
Cosine squared theta, cosine theta, that's good. Cotangent is really cosine theta over sine theta. And then you get this 1 plus sine theta hanging out over here.
Yeah.
So do you see that cosine and cosine give you the cosine squared?
I do see that, yes.
So those cancel. And now you gotta be careful here because you gotta, and you're a good math student, so you probably already can see this, but it's 1 plus sine theta over sine theta -1.
Yeah.
Okay. Now let's just make this a common denominator.
Okay.
So it becomes 1 plus sine theta minus sine theta all over sine theta. Cancel.
1 over sine theta, which is cosecant.
Yes. Now, keep in mind here, I already know how to do all these because I mean, I've done this for a long time, and like you notice patterns when you do these over and over again. You will not always know the right thing to do, and it's hard for me to teach this because you kind of need to know the right step to be able to do any of this. So that's why you got to do a lot of practice. Like there's no like what they call silver bullet. There's just there really isn't. You just have to do enough of these where you see, oh, when it's one of these, I do this. When it's one of these, I do this.
Yeah. That's kind of what he said in class. Was like, there's not a really right way to do any of this. You just notice patterns and trends.
Yes. And I wish there was a better answer to that, because that to me really isn't math. Math has like a recipe or like a set of steps that we always know to do, and they work most of the time. But these don't have that in some cases.
Yeah, no, not really.
Okay, so here's 24. So you're on a real good math trajectory. Other math classes are like this, where you try something and hopefully it works. And this becomes a more common theme in math, believe it or not.
Okay.
So which side would you work on here?
I'm not really sure.
So on the left, you have a difference or sum.
Yeah.
Kind of fraction. On the right, you just have a single fraction.
I kind of want to use the left side because it's kind of nice to just have one fraction.
Yes. So generally speaking, whenever you have a sum or difference, you work on that side, because it's easier to take a sum or a difference into a product than the other way. It can be done, but it's just more difficult. All right. Now on the left side here, you got this 1 minus tangent x. That's screaming like let's multiply by 1 plus tangent x. You agree with that?
I 100% agree with that.
And that's a common strategy here to do. So it's 1 minus tangent x, 1 plus tangent x. So on the bottom, you get 1 minus tangent squared x. Okay, but that is not an identity.
Yes.
So that's where it's like, oh shoot, what do I do? That didn't work out. But it would be really easy to think that is an identity. And it is.
It's kind of like the cotangent, which is, I believe it's cosecant squared.
Yeah, so this is going down the wrong path. Like normally that works, but not in this problem. So what's another strategy that you learned or something else that you might think to do here? So one of the very first strategies is to write everything in terms of sine and cosine.
Cosine, okay, yeah. That was my next guess, was to use, the whole tangent as sine over cosine.
So we can make a common denominator here on the bottom. So it's cosine x minus cosine x over cosine x minus sine x all over cosine x.
Okay.
It didn't get better, but we're moving. We're in a direction. So this thing on the right here, you flip it because you're dividing here, so you end up getting cosine squared x over cosine x minus sine x.
Okay.
And you get a cosine x over here.
Okay.
Now, if you look at the final answer, what does the final answer have on the bottom?
Sine x minus cosine x.
And what do we have on the bottom?
Sine x minus cosine x. So you probably want to leave that.
You can, but it's in the wrong order. So you can actually apply this negative to down here. This is one of the more advanced techniques, and you just switch the order. So it becomes sine x minus cosine x. Because you make this one negative cosine x, so it goes over here. Make that negative sine x positive.
Perfect. That's really nice to know, because
yes, you will see that again. That's why you got to know where you're going. You got to know what defense you're playing, or whatever analogy you want to make. Like I feel like we're on the right track now.
Yeah, I feel like we're actually getting somewhere.
Whereas before, we weren't. So because the final answer only has one fraction, we're going to multiply this one by sine x minus cosine x, sine x minus cosine x, top and bottom.
Okay, I figured.
So that becomes sine x minus cosine x times cosine x. Maybe we do want to distribute in, I'm not sure yet, all over sine x minus cosine x.
Okay.
So you get so deep into these problems, like sometimes you forget like what you're actually doing. Here, if you do distribute this cosine, you get sine x cosine x minus cosine squared x plus cosine squared x over sine x minus cosine x.
And like the first thing I see is just cancel out. Exactly.
Yep. And now you get your final answer.
Yeah, that worked out a lot nicer than it looked like it was going to work out.
Yeah. So I said this earlier. Let me go back and pull this this question down again. So like this is a really good question. Like this is, you just said, hey, this is probably something I might see on my test. So here's what your instructor would probably give you: sine x minus sine x over 1 minus cotangent x. So I don't know what this equals, but if you do the same set of steps, you will get something really similar to this.
Okay.
And that's how you practice these when you run out of problems to try, which maybe you haven't gotten there yet, but there's just so many that I don't know how you just, I guess you just do a few and
Yeah.
see if it makes sense. 26 we should do.
Okay.
It's cut off on the right side. Boy, that was no good.
Oh, I can figure out what it is. Hold on,
yeah.
give me a sec. Look right here. Can you see what page this is on? Because that's going to save me a lot of time.
Yes, give me just a moment here.
Never mind, I'm already there.
Yeah.
Which one do you want to do? 26?
Yeah. What's the right hand side here?
What? Hold on. Oh, the right hand side is tangent of x.
Okay.
Great. Okay, so the first thing. Okay, I already know this. It's really easy. This is a really easy problem.
It is, because you know something. What do you know?
It's like the cofunction identities.
Exactly.
And so I already know that cosine of pi divided by 2 minus x, or pi over 2 minus x, is their cofunction.
Mhm.
Yeah. And so
it's
it's just going to end up being sine, and then the bottom will end up being cosine, and that's tangent of x.
So if you don't know the cofunctions, can you do this problem?
Probably not.
No. So trigonometry is very heavy on memorization, really heavy, way worse than other classes. And it's repeated in like when you take calculus 2, you basically use everything you used in trigonometry like every day, and you're expected to know it. And it's really heavy with memorization. So whatever you need to do to memorize this, or beg your instructor to have a cheat sheet, which you probably won't get, like you need to know these things really well.
Yeah.
Because you just can't do it otherwise. All right.
Yeah.
27. You've got it in front of you. I'm not gonna write it. I'm not gonna write it down. What you're using there are the even and odd properties of sine and cosine.
Yeah, because it's going to be negative cosecant of x over negative secant of x, and then we just.
Yes. So if you don't know those things, you just can't do the problem.
Actually, can we work that one out real quick?
Yeah, of course. Let me get it up here. Sorry, I get my snipping thing here. There we go. Okay, so really in what you want to do is write cosecant as sine of 1 over sine of minus x, and secant as 1 over cosine of minus x.
Yeah.
And what it is you remember y equals x squared. Remember, it's symmetric over the y-axis. That's because it's an even function. Okay, when you put negative x in here, you get the same value. Well, cosine of minus x equals cosine of x. Well, why is that? Well, when you graph a cosine, remember, it starts high, goes low, comes back, right? Well, it's mirrored on this side over here.
Yeah, but sine isn't. Sine is odd.
Sine is odd. So that's why the sine of minus x is equal to minus sine x. If you think about the most basic function you know, which is y equals x, it has what is called point symmetry, because this top right part is rotated 180 degrees about the origin That's what makes it an odd function. And you know this about sine. If you graph sine, it goes high and then comes back down and goes like this. But it's literally rotated about this point here. You can see that. See how this part is rotated down here?
Yeah.
And then similarly like that. So now that you know those things, you can actually do something about it. It's 1 over minus sine of x over 1 over cosine of x. So in one case, the negative comes out, and the other case, it's consumed.
Okay. I think.
So it's like, do you see? All I did was take it out, and then.
Yeah. So
Okay,
mine structure is really heavy on like kind of showing off the side what happens. So how would I show that cosine of negative x is just cosine of x?
you just write that somewhere.
Okay.
You just, I don't know, off to the side.
Yeah, because he's like really big on that, like proving like if I were to substitute, okay, let's say I was gonna do like
like one of the Pythagorean identities. Do you have to actually say like sine squared theta plus cosine squared theta equals 1, and then solve for like cosine squared theta equals 1 minus sine squared theta?
Well, he's not as big as like on the main ones, but like let's say tangent squared theta plus 1 equals secant squared theta. He would want us to show that tangent squared theta is secant squared theta minus 1.
Okay. Yeah, so you got to write it down. Like you give your instructor what they want. If they say you must do this, you must do this.
Okay, but yeah, that makes more sense.
Okay. Now, to actually get to the final answer, like, and I forget, I've got another screen here, but like, we're trying to get to this. This is our target here.
Yeah.
This is not that, but if you multiply by the reciprocal, like this, you get cosine x over minus sine x, and you have to write this, even though it's that, you need to close the loop. Like you have to,
exactly.
Your final lines need to look exactly the same.
Yeah. All right, cool. Thank you.
Of course. So, why don't you pick some, or you said you had another page?
Yeah, do you want me to send you that second page?
Yeah, that'd be great.
The problems are a little bit more, not even advanced, but just a little more complicated and number heavy almost.
Sure.
All right, yeah, I have the page up. I'll go ahead and send that over to you. Oh, wait, this isn't it. This is. Actually, let me.
All right, I got it there. Thank you.
Okay, cool. And I think the one I've already done is 44. And no, maybe that's not it. Maybe it's 42.
Which one do you want us to do next, or do?
It doesn't really matter to me.
Okay, 42 is good. I mean, any of these are good. These are your test questions, it looks like. So,
all right, let's just choose one. You said 42 is good?
40, 42. We kind of already
start with 40.
Okay.
Who's Paul?
So Paul works for me. Paul is a physics expert. I do physics, but he's way better than me at it. He's got a degree in physics and he likes it. I don't like physics. So I found that it's better to go and get help from someone who like really loves that subject, and he is the best at it. So if you're taking physics or you know someone that needs help with physics, please consider him.
All right, cool. I was just looking through the page. Like, it's the first time we've scheduled a tutoring session in.
Yeah,
It
in a
seems like
while.
forever.
You might also like some of the stuff I posted on social media. Doing some other stuff here. Let me just really quickly show you some of these problems. You've probably already seen some of these, but I'll snip one in here. If you'll consider following me, my business account here. I'm posting some, I get what I hope is more interesting stuff here. You've probably seen these kinds of problems before.
Oh yeah, these are actually really I actually really enjoy these problems.
So I actually made them more difficult because the ones I found were too easy. So they're actually, this one doesn't have it, but some have multiple solutions to them. And
Oh Jesus.
yeah. But check me out there at Instagram, Facebook, and Twitter, whatever you like to do. But let's get back to the fun problems here.
Oh yay.
All right. There's so much here. I guess I'm tempted to divide both of these by sign, because that makes one and that makes cotangent. But I'm not
Yeah.
convinced that that's the right thing to do. But because it's negative cotangent and there's a cotangent here, it kind of works out. It's like you almost have to look ahead and say, okay, well, that's
That's actually one of the first things I saw was the whole cosine. Well, it's going to be negative cotangent, and that's going to cancel really nicely.
Those cancel +1. Okay, so now I guess we're going to just distribute in because we don't know any better. Cosecant squared x minus. Now, instead of cosecant, we can write it as 1 over sine x times sine x +1.
Okay.
So that's cosecant squared x minus 1 plus 1, and we have it.
Yeah, that was.
But I should caution you, like you had to look ahead. You had to see like, oh, that could cancel, because if you're like, oh, let me divide this by sine x, let me divide cotangent by sine x. Some students in your class might do that, and it still could get you to the right answer. It's just not the right thing to do here. And that's why instructor said you got to just do a lot of these. You got to just do a lot of practice. So.
Yeah.
Okay, let's look at 42. I'm trying to remember.
Not even speaking into my mic. Sorry.
Oh, that's great. I can hear you just fine. I'm trying to find problems here where I can have more commentary for you. They all kind of fit into a funnel of like these problems you always do this, these problems you always do this, whatever that is.
Oh, this might be the one. I don't know. Okay, let's do this one. This might not be it, but
so we haven't, like, all of these, the way these problems get harder is they utilize things you've already learned in algebra. Like, we've done a lot of factoring, we've done some fractions, we've done some complex fractions, we've done other types of factoring besides GCF is like difference of squares and a equals 1 trinomials. Like you're just reusing stuff you learned in a previous class. But here, these two, what can you factor out of these two?
You can factor out tangent squared.
Right. And why would I do that? Well, I can look ahead and tell you that, oh,
yeah, this
good.
Is the problem I did in class. I've done this problem in class before.
Great. Because that helps you do this.
Yeah.
Otherwise, you don't have much of a chance here. Now, tangent squared x times secant squared x minus 3. Okay, so that is not this over here on the
no,
right.
It's not.
So what did you end up doing in class? Did you work on the right hand side?
I believe the right hand side is what you have to work on.
Okay, so you're saying, so basically you're telling me, hey Matthew, we worked on the wrong side. And that's true. Some instructors actually allow you to work on both sides. They don't make you pick a side, but you work on this one to make it look like that. So let's work on the right side. What did you do first?
Okay, from what I remember, we have to factor. Like,
you mean
if we
factor, or
maybe I haven't done this problem. I'm not sure. I remember. Okay, yeah, maybe we just distribute and see what happens. I'm not sure.
Okay, so another option here. Do you see how this left side only has tangents?
Yeah, but the other side
As
does
a
not
sec,
just have tangents.
but what is so? What is secant squared x?
Uh, okay. Yep.
Now, what do you see here? You can FOIL this.
Yeah.
So 4 tangent squared x. Okay, now we got to do the outer -3. Inner is 4 tangent to the 4th x -3. I guess I got some -3 tangent squared x. Did I? 4 tangent squared x -3. 1 plus is. Let me make sure I got that identity right. Did I?
Yeah, it might. It's tangent plus 1, but that shouldn't really change anything.
No, that won't tangent. So I'm sorry. Let's maybe get my phone right here. It's 4 tangent squared. Okay, 4 tangent to the 4th x, and then then you get -3 tangent squared, and then -3. Okay, that's it. Yeah. So we've got
Yeah, I see it.
these two combine. So that gives you 4 tangent to the 4th x plus tangent squared x -3. Wonder if there's a typo. I mean, that is it. That is the solution here. You do this, then you FOIL. But it seems like there should be
Let
a
me
4
look at
there.
42. And actually, if we have any questions, I can, my teacher has like the book. I don't know why every student doesn't buy, and it has every answer in the book.
Yeah, you definitely should do that. There's also a lot of online platforms that have answers now, so consider looking at those.
Okay. Yeah, because that's really weird.
Yeah, I'm almost. I mean, I've seen that. It wouldn't surprise me that there was an error here, but you can see it when you FOIL this. You get 4 tangent to the 4th, 4 tangent squared, 4 tangent to the 4th. So I think there should be a 4 here. But let's move on to another question. I mean, you understand how to do this. That's the
Yeah.
point here, is knowing the strategy. So let's look at 44.
Okay.
Yeah, maybe ask your instructor, say, I worked this out on my own. It looks like there's an error on this, there should be a 4 there, maybe get some extra credit.
Maybe that'd be nice.
Okay. So the left side is more complicated.
Definitely.
Anything stand out to you specifically here?
Well, I know. Oh yeah, that's kind of. Oh, that what's it called? Factor.
Yeah, so if you don't see it with the signs, it is okay to write this and then be like, oh yeah, that's x squared minus 1 squared. You just have to remember what x is. X is that sine to the 4th. So, or sine beta. So this is sine squared beta minus 1 squared, because your x is really sine squared beta.
Okay.
Or sine beta, depending on how you do it. Okay, cosine beta. But this part inside here, what is that?
Oh, that's going to be a cosine.
It is, but you probably have to show a lower curve, like sine squared beta plus cosine squared beta equals 1. If you subtract 1, that equals minus cosine squared beta, because you have to minus it.
Okay.
So if I were your instructor and you didn't put the negative in there, I might wonder if you actually just knew that this worked, or you were sloppy. You don't want to take a chance here.
Okay.
Even though it cancels out, you still don't want to do that. You want to, like we said this before, the emphasis is on showing every step. So this becomes cosine to the 5th beta.
Okay, yeah.
Can I really quickly show you a calculus problem so you know why you're learning all this stuff?
Sure, sure.
Okay, so there's a problem in calculus. They give you sine cubed x cosine x like this dx. And don't worry about what this is. Maybe you've even seen it before, but students have to remember that this is sine x, sine squared x, cosine x, and that sine squared x is 1 minus cosine squared x. And then you do some other things here, but you end up getting cosine x minus cosine cubed x. And all of this in here that I did is not calculus. This is trig. This is the class you're taking right now. And you're going to take calculus, and you're going to take calculus 2 someday, I'm predicting. Like, this is why you're learning it. Like, you are going to use this stuff. And I get students all the time that have no idea. They're like, oh yeah, I forgot. I got to show them the cheat sheet. So if you like math and you think you're going to take more math, like, there is value in what you're learning here today. Maybe not these verify the identities, but all the stuff in that cheat sheet where you got Pythagorean identities and cofunctions, like that all comes back into play.
Yeah, my like my school's like really proactive on like what you want to take. So my counselor already wants me to take next year. I'll take either honors pre-calc or pre-calc. I don't know. This class is pretty difficult. So I don't know how honors pre-calc will end up being, but if I end up taking honors pre-calc or pre-calc, and then they want me to take some calculus and then AP stats.
Right.
And I really like statistics. I don't know if you know that, but I really liked statistics. So
yeah, that's my background, statistics and probability. That's what I've written some papers on. So it's a fun area of math. But just there is a reason you're learning this. It's not for this test. It's actually for other stuff down the road that you draw on this information. And when you're practicing hockey, you've probably done drills. You're like, why am I doing this drill? And then you like realize in the game, you're like, oh, that's why I'm doing this drill, because
exactly
that's what it is here. So it's up to you how much you want to put into this. We have time to do probably another problem or two here, but really that is why we're doing it. It's for, you will see this again if you take more math. It sounds like you will. You won't see it in calculus 1, but you will see it in calculus 2 or calculus BC if you take it in high school.
Yeah, they don't mean it. Is it calculus ABBC? Is that how they do it?
So for some reason, high schools, they say calculus AB, that's your first class, and then calculus BC, and there's this overlap. So you end up seeing like some of the same stuff in both classes. Whereas when you go to colleges, they just call it calculus 1 and calculus 2. And there's this clear division like that. But in high school, for some reason, the AP classes, they overlap. And that's why they call it AB and BC, because there's some overlap. And
okay, yeah.
I don't know. All right, let's look at this last problem here. Let's see if we can get through here. We've got 3 minutes. Which side is more complicated?
Oh, this is one of those dumb problems where neither side is more complicated. You just got to choose one and pray.
So I would argue the left one is more complicated because it's got a sum in the denominator. That's like some instructors actually make you write why you chose the left side or the right side.
Oh, that's dumb. I don't want to do that.
But if you're not sure, just have some like know why you're doing it. I'm trying to go back and find the identities. Do you have your identities out in front of you?
Yeah.
Okay, so if we work on the left side, you probably know to multiply by the conjugate.
Yeah.
But you got to make sure, and that's why I was going to grab my identities, is cosecant squared minus 1 an identity?
It is. It's cotangent squared.
It is. So that one works out. But if it wasn't an identity, then that's not the right step to take. But this one does work out. So the numerator is cotangent alpha, cosecant alpha, and you want to avoid distributing. You may do that, but like you want to be sure that you have a good reason to do that. And in this problem, because the bottom becomes, you just said it, cotangent squared alpha, one of those is going to cancel. This one cancels with that one.
Yeah. And so we end up getting what we wanted.
Is that what we wanted? I lose track when I do these. So.
I think that is what we wanted. I could be wrong.
It says +1.
Oh, what?
Yeah. So we're not done. Cosecant alpha +1. -1. Wow. I think there's a mistake. I think that should be -1 because we're done. We've got it. Yeah, I would ask about this one, and I would ask about 42 if you have time, because they do seem to be inconsistent. Like this is the right approach to take to get there.
Yeah, if you you send these by email, right?
Yeah, I'm gonna send you the notes here in like 2 minutes after the lesson.
All right, yeah.
All right.
Well, how much time do we have left? We're done?
We're actually done. So thank you, Zane, for scheduling.
Yeah, no problem.
If I can help you again, please let me know. And
Yeah.
hope all is well for you and your family.
Yeah, we're doing pretty good.
Awesome. So I'll send you the notes here shortly.
All right, cool. Thank you.
You're welcome. Bye now.
All right, have a nice night.
You too.